Novice programmers, after learning the basics, find ourselves often typing out code we believe is error-free, only to then compile it and find bugs littered throughout. It happens so frequently we eventually give in and learn to expect it. Sometimes we still think if we learn the rules well enough, it will eventually stop happening. Then we learn how to work with multiple classes, multiple programs, other languages, and find whole new sets of bugs that we weren't prepared for. Bugs are a fact of life for programmers, and as the program's design becomes more complex, so too will the skill needed to debug it. There are many different types of bugs or errors, which can require different methods of problem solving. For that reason, there's no one right way to debug code. For a list of common bugs, refer to your worksheet. If you do not have a worksheet, expect it in the post. For now, let's classify them into 1. Critical bugs. Bugs that crash the system or kill the dog. 2. High priority. Those that cause mayhem within the system, or send the dog to the vet, costing you a small fortune. 3. Medium priority. Those that cause error messages, like your dog soiling the carpet. 4. Low priority. Those minor infractions that only pop up once in a while, not affecting a great deal. Like your dog begging guests for table scraps. It may annoy them, but you can live with it. When it comes to low and even sometimes medium priority bugs, a company or programmer should evaluate whether it's better to fix the bug, find a way around it, or just leave it in the code. If it's not popping up very often or is obscured in some way from the user, it may cost too much to fix it. Depending on the error, it might also cause more hassle than it's worth, particularly if it ends up springing a leak full of hidden bugs. But let's just assume for now that your boss did not greenlight you pretending the critters don't exist. So you're sitting in front of your desk with hundreds or thousands of lines of code on the screen that either don't compile or don't compile into what you thought they would. What now? Throw the computer to the ground? You might have to pay for that. Right about now, or later, future you is thinking, I wish I had paid attention in that class where we learned different methods for debugging. Don't fret, we've got you covered. Store that worksheet we handed out, which includes links to these videos, in a safe place for future you to run to in their time of need. Tell future you to take a deep breath and evaluate the methodologies. First, there is the send it away method and let the gods fix it. Unfortunately, Ask Eager shut down, so that's out. Oh, no. A similar technique is remote debugging. Whether your debugger is located on a different system from the one your program is run on, where your debugger is located on a different system than the one your program is run on. This isolates your code. It ensures that the problem is the code itself and not the system. The downside is it's not the easiest thing for a novice programmer to wrap their head around and get working in a timely manner. What may be easier is getting a fellow programmer to look at it. Peer reviews, as a methodology, comes in 2 forms, formal and informal. A formal peer review is usually instigated by management as a part of the development process, whereas asking a peer to review your work is more of an informal way to figure out how to fix the problem. You don't want to rely on this often because it takes away from them doing their own work. A modern workaround for this is called pair programming, where one colleague writes code as the other hovers beside them saying, you missed a spot. The two then switch positions every few minutes. If done correctly, this method encourages teamwork, error avoidance, and quick debugging. If performed incorrectly, it encourages nagging, retaliation, and keyed cars. If you don't want to talk to that colleague ever again, you can always talk to a rubber duck. After all, the best way to learn is to teach.